Welcome to another GibbsCAM version 14 series of videos. Today we're going to show you how to program a 2-axis lathe part. So let's get started. First I'm going to go to File and New, and I'm going to put it in my folder wherever you'd like to put it. I'm just going to call it 2-axis turning. Save that. Now before you import your file, you want to make sure you've chosen the correct machine. So I'm going to go to Document Control, make sure you're on the lathe, in this case a horizontal lathe. If you were doing, of course, a live tooling lathe, you would choose a C-axis horizontal lathe, but we're just doing a standard 2-axis lathe. And of course, if you have an MTM type lathe with live tooling, you will more than likely have a MDD in your exact name in this list here, but we're just doing a 2-axis lathe. Don't worry about any of this yet. Now I'm going to go to File and I'm going to import my model, and we don't want to mill parts. I'm going to go back here to do turning, and we're going to start with lathe part number 5. So this is a solid model here, and Gibbs is going to bring it in according to how the engineer drew the part in, say, SolidWorks in this case. So you can see it's pointing, of course, in the wrong direction. This might be the case for many lathe parts. You may not have it oriented correctly, and the origin may not be in the front. It may be in the middle, for instance, or on the back. I'm just going to move this origin for just a second so you can see how to fix that. So let's say the engineer drew the part and he put his origin in the middle of the lathe part, so that's okay. So first thing we're going to do is click on the lathe part, the solid, go to Modify and go to 2D Rotate, and I'm going to rotate it in the XZ plane, 0, 0, and of course 9 degrees, and we want to go clockwise. And as you can see, it puts it rotates at 90 degrees, but the origin is, of course, still in the middle, and I want the origin at the front of the part, which is most common. So the next thing you want to do is modify and do a shrink wrap, either shrink wrap visible or shrink wrap. Either one will do the same thing because this is the only part on our screen. Okay, once you've done that, Gibbs wraps geometry, well, stock size around the part, so you can actually see the size of the part. So now go to your document page, and of course choose your material. We'll just say aluminum in this case. And these are very important now. Make sure you're in inches if you're programming in inches and your lathe is set to inches. The mill class really doesn't matter. You can change that to none or you can leave it. The shank in this particular case that I'm going to use is 1 inch. You can see you can choose the different shanks there. That's the square shank of the tools that go in your turret. And of course we want to program in diameter, so make sure that's selected. And in this case, if the last part you did was in radius, it's probably going to stay radius, so don't forget to do a shrink wrap again just to update those values. Now by doing a shrink wrap, you can see where the origin is compared to the front of the part, and I can see, oh, the origin is 3 inches back. Well, I don't want that. I want it in the front. So just go to Modify, Move Part Origin. We'll move it 3 inches in Z. And of course nothing else, and now our origin is in the front of the part, and you can see it updated this as well. So once you've done that, then we need to fill in the rest of the stuff here. So the Z max, this is how much material is on the front of the part. So I'm just going to say there's a 60 thou on the front of the part. And in this case, I'm just going to hold the back of it with the chuck, so we won't worry about the Z negative value for this part here. And if you're not doing MTM and pulling with subspindle, things like that, you can normally just leave these blank here. We're of course programming in diameter, and these two here are very important. You can use auto clearance. Most of the time I don't. I like to use can cycles, and sometimes auto clearance doesn't give you can cycles, so I like to use can cycles as much as I can. So these two here are where the tool goes before it goes home to do a turret change. So obviously you want these bigger than your stock size here. So since our stock size is 6 inches, I'm going to say 6.2, That'll give me 200 thou clearance, 100 thou on each side, and I'm going to say we'll say 0.2 on the Z as well. So that way the tool will always go to these two places before it starts cutting, and go to these two places before it goes home and does a turret change. Now normally you don't need to use this box here. This would be, say you had a lathe with a very long bed and you didn't want it to go clear home to the end of the Z before it did a tool change. But normally your post takes care of that, so normally you don't need to use this. It'll go to the tool change position and then change tools and come back. So normally I don't change this here, so let's close that. Okay. Now there's a couple of ways to pull geometry off your part. If you have the 2.5D solids or solid surfacer, then it comes with this profiler here. So if you want to do slice this part very easily, you can go down to this second one down where it says slice spun body, and there's the geometry, and most of the time you could machine it from here, but most of the time I like to extract the geometry off there. Close the profiler, and there's your geometry all ready to go. The second way to do it is using the slice plane. Now if you have just a regular, if you don't have solid surfacer 2.5D, you won't have the profiler, so you can go down to the plugins, and if you don't have this menu called Get Section, you'll have to turn it on. Normally it's turned off, but if you go into the plugin manager, go down to Get Section, normally it's not checked, but if you check it and click Apply, then when you go to Plugins, it'll appear right here. So it says select a solid first, so we'll select the solid, go down to Get Section. Normally you can just leave the defaults here, which is fine. Click OK, and there's the geometry as well. The one thing you need to be aware of is, of course, if it's a 2-axis lathe part, you won't have any grooves or slots or keyways. But if it does have keyways, things like that, then when you do slice plane, it's going to slice through the keyway, so it may not give you the turned diameter you're looking for. And that's where this comes in really well, because it doesn't matter whether you have holes, keyways, or anything. When you do a spun slice plane, a slice spun body, it'll ignore all those and give you the nice turned part there. So a couple ways to do that. Okay, let's create some tools now. I'm just going to bring in the tools that I already saved for this part, and then we'll kind of go through those. So I'm going to just right click on here, load tools from what I've saved already. Click open, and there's my tool. Actually I only saved one tool, so we'll create the other ones on the fly. So this first one here is just going to be an 80-degree diamond, 1/32 tool nose radius, inscribed diameter 1/2 inch, 1/8 inch thickness. You can choose either one of those. It really doesn't make a difference on the G-code output. And it's sitting in the turret this direction. Now if you want to see the actual tool shank, click on this. You can zoom this up if you like. And you would choose tool holder. If you click none, it's just going to show you the insert. Tool holder, it's going to show you the tool and the shank. This holder length, normally I just do that just to show you the length of the tool. It's not going to make any difference on the output, but if I put 6 inches in there, you can see that changes that there, so I'll change that back to 4 inches. And I always put the description down here as well, and the type it is of insert. And you can see this scroll down bar here, you can see that changes. That's a 15-degree. You can see all the different ones there. Neutral tool. So if you look up here, you can see this 5-degree face relief. So you can see you want to have a 5-degree face relief. That's the most common that you're going to use there. Okay, let's just close that. Let's make a new tool. That'll be for our facing and roughing of the part. Our next tool is going to be a 55-degree, and it's going to be a 64th tool nose radius. Again, I'm going to choose 1/2 inch IC, and make sure the tool holder's on there so I can see the shank of the tool, and I'm going to click on tool holder. And you can see this has a 17.5 face relief. That's standard ANSI holder, but not too common. So scroll down one, and you should see 5-degree face relief, which is what we want. So I'm going to put in here finish, face, and OD. And that's going to be offset number 2. As you can see, the first one is going to be offset number 1. That means it's going to put it in your turret in station number 1, which will be normally T0101. This one will be T0202. Normally you don't need this tool ID on. That only comes into play usually when you're running MTM, so don't worry about that. This is spindle direction forward. Of course, that's your standard M3, so your tools will be upside down in your turret. That's your standard direction there. You want the chips to be forced down to the machine bed rather than up against the door. So the last tool you want to create is a grooving tool. It can be a groove tool. These are 300 thou wide. I dimension that. You can see 300 thousandths wide. So I'm going to choose a 1/4 inch wide grooving tool. You can create other and put in the custom size if you want, but that's normally I only use that if I have some special tools. Here, normally I don't choose tool holder. I just click on none because that can change depending on what brand of tool holder you have. And of course, this is going to be just 0 degrees. And this right here, this means you're going to touch this corner off your presetter, your tool presetter. So this is where the values are coming from. Of course, if you click over here, that means you touch your presetter off this side, and all the values in your part will be off that. But we want this one here. Okay, this one I'm going to just call it grooves. Okay, so we're all set now. Okay, I'm going to turn off my dimensions. So let's open up our cam now. This time I'm going to just choose, I'm going to take multiple passes on the face, so I want to do a roughing. If I was just taking one pass, I would choose contour, but here we're going to choose roughing with that tool, of course. Here I'm going to do a front face. So here's my rapid 2 point, 0.2. When we're done cutting, it's going to go to 0.2 again, which is fine. And this is my cut depth. How much do I want to take per pass? Well, I'm going to say we're going to do it a couple passes, so I'm just going to say about 30 thou per pass on here. I'm going to click on full, and I'm going to not leave any stock on the OD because we're cutting the face, and I'm going to leave about 3 thou on the Z, which is just fine. CSS stands for constant surface feed. Okay, and this is going to be your max RPM. That's not the max RPM your machine will do. It's the max RPM you dare to let it go. So I'm going to say 2,000. This is your surface feet per minute. Of course, if I was doing aluminum, I'd be going at least 500. Entry feed, 12 thousandths is a good place to start. Okay, and I want to use a can cycle. All right, that'll write the G72 can cycle, which is the most normal cycle for most machines. So I'm going to click on the face there, drag the white one off my part there, arrow down because we're cutting from top down, and black marker, snap it right to X0, Z0. Don't put it past here. There's no need to put it past, just put it right on there. Since it has a 30-second tool nose radius, Gibbs will automatically force it to minus 0.0625, which is the radial value of the insert, so it doesn't have a little island sticking on the front there. So then click on Do It, and you have your roughed face. The next thing I'm going to do, still use the same process. We're going to change it to OD because I'm using the same tool. This is where it's going to wrap it to that we put in our document page right at the beginning. And this here is where is the material that you're going to cut. Well, it's 6 inches. We're going to start right at 6 inches because that's going to be our stock size there. Our depth of cut, we'll start at 1/8 of an inch. This time I'm going to leave 10 thou per side for finish. Again, everything else here the same, and I'm going to show you something on here which we'll want to change. So I'm going to click on this little chamfer here. I'm going to drag it off my part a little bit. You can always right click and say move to a certain amount, or thou if you want. And then a trick to use to bring it back here is hold down the control key and the shift key and click on the line you want to finish. Since we're holding on the jaws here, I'm just going to pull it about halfway back there. If you wanted it exact, you could put a point here and have it snap to that point. So we're all good there. So click on do it, and it all looks good. Now let's render this so far so you can see what it's going to do. Do a full diameter. And let's slow it down a little bit. It was a little fast. Okay. Now we're going, of course, the wrong direction there. So I'm going to click on a few things and change this. Last part we did was go in the other direction, so I'm going to click on forward, make sure that's on forward. And same with this one, forward. Normally that's checked on, but depending on the last part you did. So now we need to take a finish pass, so let's bring up a contour with tool number 2. And again, we're going to start at X0. And when we're done, go to 6.2 before it goes to the turret location for the next tool. And we're going to do a 50 thou line in, so it comes down, goes in 50 thou, then off our part here. So 7 thou is pretty good for that. We'll have it on full. Everything here looks good. Uncheck X minus so it doesn't go down into the grooves. And we're going to click on the face. Down there, arrow up. Again, Control Shift. Put it about there. And click on do it. And then we have our finished pass there. And if we do a cut part render, you're going to see that. So let's rewind it. Let's actually turn on color so we can see the tool. So I'm going to click on tool number, different colors. And let's play it. There's our roughing, come back finish, and there we have it, finished turn. So the last thing we need to do is the grooves. Okay, so let's clear this. And normally with grooves I bring up 2 processes here. I'm going to bring up a roughing process with the roughing tool. The roughing groove tool, well, it's the same tool we're going to use for roughing and finishing here. So here, I don't want to, of course, wrap it to 0 because down through here, it'd be really bad. So I'm going to highlight this box, hold the Alt key down, click on this point on the corner there. I could click there or over there, either one doesn't matter. As long as you get the point correct, it's 1.6 there. Of course, I don't want to wrap it to there, so I'm going to say 1.650. And when I'm done, 1.650. And here is the diameter that we're actually going to cut, so I'm just going to alt click right there, and it's 1.6. So that looks good right there. Okay, we're doing roughing. I want to do material only, which means Gibbs is only going to cut where there is material left. And I'm going to leave this at 20 thou on material only, so it'll move the tool around the part and stay 20 thou away from any material. Now normally here I don't want to put XR stock and Z stock because it'll force the tool to the right, and if you're too close you might hit this side here. So what I want to do is put 5 thou all the inside of this groove on all sides there. So 5 thou, it'll leave this everywhere on here. And instead of doing turn, I'm going to do a plunge. And normally if you're doing OD, it'll automatically put a -90 in there. So cut width, you can choose how you want to do it. Exact, you want it to step over 100 thou each time, or calculate. You can say the maximum amount you want it to go. So we're 1/4 inch wide grooving tool, so I'm going to say 150 is the max I'm going to let you move each time it plunges. And normally I do center out cuts, which means it's going to always start in the center and go to the sides, each sides, no matter if it's 300 thou here or 3 inches wide, it's going to start in the center. Okay, you can do multi-pass if you want, so it's going to step down. Normally I don't do that. Plunge type, we're going to do plunge. If you have really sticky material, you might want to do PEC full out or PEC retract, so you need to choose the best one for you. First feed, I'll just leave that at 50% there. And normally, grooving tools, I normally start out at 3 thou per rev, which is pretty good. Okay, all is good there. Okay, now the next one I'm going to put in right below it, the second process, contour with the same tool. Again, OD, our numbers there look good. We're going to do material only again, 20 thou, leave no stock. And I'm going to click on this. Well, we'll leave this unchecked for the moment until and then you can see what it's going to do. Again, feed right there. So all I really need to do is select somewhere here and Control Shift and click on Do It, and there's our tool path. And why you're seeing it over to this side is it's looking at the left side of the insert, so that's why you're seeing this like this. So if we cut part render, now you're going to see what it's going to do. So we'll kind of center this a little bit and show you cut part rendering. So when we bring up cut part rendering, I'm going to bring up the little stop sign here and say stop before operation number 4. Okay, we'll click on play. We'll speed this up a little bit. Alright, now I'm going to slow it down. And notice on this tool how it cuts. So it's cutting to the side. Of course, it's not going 150 thou wide because it can't, because it's 300 thou wide. Now you can see when it finished, it dropped the tool down, went across, and drug it up the back side, which is normally not very good. Usually squeals the tool and doesn't leave a very good finish. So what I'm going to do there is I'm going to change this finish one and click on this button that says no drag and redo it. That's going to not let it drag up the side. So let's go to cut part render again. Speed it up, slow it down. Okay, watch this time now. It's grooving, and then the finish pass, you can see goes there, then it pushes, goes down, so it pushes, so it leaves a nice finish on there. So that's how you do 2-axis lathe turning. Any questions, you can leave a comment below. Thanks for watching.